Our fictional application here has a hot water circulating pump, and it has to run before our boilers can be enabled. It also has to run for 10 minutes after our boilers turn off. We're going to enable the pump with a schedule, and outside air has to be below 65 degrees as well. So I'm going to start with my hot water pump, but before I do that, I'm going to add a couple of text blocks to my page just to show you how I want to organize my wire sheet as I go. So I'll add a new text block, hit OK, and I'll double click it, and in the text field I'll put inputs. Save, go back to my wire sheet, and I'll put that on the left hand side at the top. I'll create another text block, and this one will say logic, and I'll put this one over here, and I'll create another text block, and this one will say outputs. And I'll put this one over here. This should help you visualize why I'm putting certain things in different areas of the wire sheet. I'll start with my hot water pump. I'm just going to create another Boolean writable and call it hot water pump, and I'll move it over here for now. I may need to move that in a little bit. And then I'm going to create another Boolean writable called hot water pump status. And that'll be an input. It'll be coming from a current switch or a flow switch out in the field. And this is just to let me know that when I call for the hot water pump, it actually came on. I'd like to know how long my pump has been running, so I'm going to add a totalizer to my status point. So I'll double click my status point, and then I'll navigate to the control palette folder in Kit Control, and open the extensions folder and drag a discrete totalizer extension onto my hot water pump status. Hit OK. And if I expand it, I can see what's going on. I don't have to do anything with this discrete totalizer extension. It just starts working. So I'll go back to my wire sheet, and I'd like to see the runtime value on this point. To do that, I need to expose the slots that I've added in the extension. And if you remember back a few labs, the way that we expose child slots on a parent point is to composite them. So I'll right click on this hot water pump status point and go down to the composite tool. I'll expand hot water pump status and expand the discrete totalizer. And then I'll double click the elapsed active time slot, not the elapsed active time numeric, but the elapsed active time slot. And as I bring it in, I'll rename this slot to runtime. I'd also like to be able to reset the elapsed active time when I right click on the point and go to the actions menu. So if I double click the reset elapsed active time slot, it will give me an action slot to do that. I'll change the name of this one to say reset runtime. Hit OK, and hit OK again. Now I have the runtime slot, and I also have the reset runtime action slot. So if I right click on this hot water pump status point and go to actions, reset runtime becomes available. Part of my sequence said that the hot water pump has to run for 10 minutes after my boilers go off. So part of that logic is going to be to add a timer block. I want to add an off delay timer in front of my hot water pump point. So back to Kit Control, timer folder. I'm going to drag over a Boolean delay, hit OK, and double click the Boolean delay to set the time. This Boolean delay can be an on delay, or it can be an off delay, or it can be both. It just depends on which property I adjust. My off delay property would get set to 10 minutes to satisfy the sequence, but for testing purposes, I'm going to put this to 10 seconds so I don't have to wait 10 minutes just to see my logic change to make sure that everything's working. When I'm done testing out all of my logic, I'll come back into this timer block and set that to 10 minutes. Hit save, go back to my wire sheet, and now I'll just link the out slot of the Boolean delay to N16 on my hot water pump. So I have part of my logic done. I'm building this a little bit at a time. If this were a real project and I had a set of control drawings in front of me, I would add all of my inputs and all of my outputs, because those are known before I even started working on logic. That way I had a template on my wire sheet and I wouldn't forget that I have something that I need to connect. But since this is not a real project and I don't have a set of control drawings, we're just doing this a little bit at a time. I'm going to add a ramp object to simulate outside air temp. So I'll come back down to the utility folder in Kit Control and grab another ramp, and I'll call this OA temp. Hit OK. Move it over here, and I'll go into the ramp and make a minor change. I want this ramp to ramp between 0 and 100 in a period of 2 minutes. So I will just put 2 minutes in here and hit 0 on my keyboard to get 2 minutes. The amplitude and the offset properties are what determine the range of this ramp. So if you think of offset as the middle point and amplitude as the range around the midpoint, we can take this one for example. If 50 is my midpoint and the amplitude is 50, that means it will go from 0 to 100 in a 2-minute time period. That's how the ramp works, and that's how the sine wave works. I'll save this, and I'll go back to my wire sheet. Then I'll add a numeric writable and call it OA lockout set point. I'll set that to 65. So we'll tackle the outside air lockout portion of this first. I need an object that will compare outside air temp with outside air lockout set point and determine when this value is lower than this value. The object I'm going to use is called a less than block. It's found in the logic folder of Kit Control, and I will just drag that over onto my page. And I'll link the outside air temp to input A of the less than block and the outside air lockout set point to input B. The way that all of the blocks work in the logic folder is if input A is whatever the name of the block is over input B, you get a true output. So in this block, if outside air temp, input A, is less than outside air lockout set point, input B, I get a true output on the block. Every one of the blocks in logic works that way. And just so I don't have to go off sheet and link my schedule to multiple objects in my wire sheet, more for demonstration purposes and teaching purposes, I'm going to add a Boolean writable called occupancy in to kind of follow the theme that we've been using throughout the course, and I'll link my weekly schedule to that. And then downstream of this point, whatever blocks I need the schedule to control, I'll link from here. It'll make it a little easier to follow the logic on the page. I'll go ahead and link the weekly schedule to it now. So in my tree, underneath my schedules folder, I have the weekly schedule. I'll right click, go down to link mark, and then I'll right click my occupancy endpoint and link from the weekly schedule. I'll come from the out slot of my source to input 16 on my target and hit OK. And now I have a block that's following the weekly schedule. If I only wanted to control the pump based on the schedule, I could drag the out slot from the occupancy in into the Boolean delay, and my pump would be controlled by the schedule. But our logic is a little bit more difficult than that. It's a little more complex. It's more designed to mirror what you would see in the real world. We need to finish programming in our limits. I'll go ahead and undo that link that I just made. That sets me back to where I was before. My sequence says that the schedule has to be on and outside air has to be less than 65. So there's another block in the logic folder that allows me to do that. If I drag over an AND block and hit OK, and I link the out slot of my less than block to input A, and the out slot of the occupancy in block to input B, the AND block will only be true when input A and input B are true. I'll go ahead and rename this block to pump enabled AND. And then I'm going to make some more room here on my wire sheet because it appears as though I'm running out of room. You may have noticed at this point that I renamed this block, but I haven't been renaming these other blocks. I'm renaming this one because it's the result of some other logic combined. And if I come back to my wire sheet in 6 months and I want to have an idea of what I was going for when I originally created the wire sheet, renaming some of these blocks gives me clues as to where my mind was when I created the original logic. So personally, I leave most of the blocks the default name when I'm bringing things over from Kit Control. But if I have something that's part of my strategy, like this pump enabled AND, I might rename that just to jog my memory next time as to what I was trying to do. You'll come up with your own methods and workflow as you do more programming. I'm just going to go with this for now. Then I'll take the result of this AND block, so the out slot, and I'll link it to the Boolean delay of the hot water pump. Now I have logic on my page that's controlling the hot water pump based on outside air temp and my schedule. The hot water pump side of our logic is done. But our boilers are continuing to run and they're not looking at the hot water pump at all at this point. So these are two individual sets of control. So now we're going to add the logic to make the boilers dependent on the hot water pump status. I'm going to add another AND block, and this one I will call boiler loop enable. I'll link the out slot of my hot water pump status to input A of the boiler loop. And then I'll come down to the pump enabled AND block and link the out slot to input B of the boiler loop enable. This AND block ties the outside air lockout and the schedule in addition to the hot water pump status. So those are tied together. And the result of this is what I'm going to use to control my boilers. So this has to be true, and this has to be true in order to get my boilers to come on. There are a few different slots that I could link this boiler loop enable to. I could come directly out of the boiler loop and go to a higher priority on the boilers. The problem I have with that is it cuts this out of the loop, and the loop point doesn't know to turn off when the boilers are not available. When you're working with control logic, you want to try and affect the outputs based on the sequence and not just go linking things to override them off when they shouldn't be on. This loop point has an enable slot on it. So if I take the boiler loop enable and I enable and disable the loop point, it will then go to 0 anytime it's not enabled, which effectively will tell the sequencer to go to 0, and the sequencer will tell the boilers to turn off. So that's how I'm going to approach this piece of logic. I'll link from the out slot of my boiler loop enable to the bar at the bottom of the loop point, and then I will select the loop enable and hit OK. And now my logic is complete. I have the outside air and the occupancy in coming into an AND. that turns on the hot water pump. I have an off delay so that the hot water pump runs for 10 minutes, but as soon as my schedule turns off or outside air goes above 65, my boiler shuts down. My pump still runs, but my boilers turn off because of this AND block. At this point, my logic isn't working quite the way that I want it to, though, because I don't have a hot water pump status. The out slot of my hot water pump status is null. If you remember back when I talked about the input priority array, if I go into this hot water pump status as a refresher, the out slot scans all of the in slots below it and sets itself to the first one it sees. If it doesn't see anything, it goes null. Null means to ignore. So if I go look at this on my wire sheet, this out is null, and so the AND block is ignoring it. What I need to do in order to test my logic is to set my hot water pump status to false and just sit and watch the process. If I follow this logic back, my hot water temp needs to get below 65. My occupancy in needs to be on. So I'm going to wait until this gets to 65 so that this block goes true, and then this pump enabled goes true. That's true. My pump is on, but my boilers are off. The thing that's holding the boiler off is this out on the loop point is at 0. It's at 0 because the boiler loop enable is false. The boiler loop enable is false because my hot water pump status is false. So all of these little things play in together. Troubleshooting is a skill that you'll learn over time. You have to break apart each little piece and follow it back. I'll start on the output side and try and follow the logic back to see what's preventing something from coming on. If I come over to the hot water pump status and I override it, I'll use the active action to do that. I'll override that for an hour and hit OK. Now my logic should work. My loop point went directly to 100%. Both boilers came on. If I didn't want that to happen in the real world, there's a property in the sequencer that I can set, and that's the delay. The delay will delay all my stages after stage 1, so stage 1 would come on immediately, and then I could have a delay in between stages. So if you're using this in the real world, delay is something to go ahead and take a look at, and you'll most likely use that in between stages to make sure that you have some kind of demand there before you bring on second, third, fourth stage. Back to my wire sheet, and this all looks good to me. The last part of this lab has you add history and alarm extensions to these points. I'll go ahead and review one of each of those, and then I'll do the rest of mine off screen. I'll go ahead and add a history to the hot water temp ramp object. So I'll double click the object, open up my history palette, open the extensions folder, and my book asks me to add a numeric COV. Drag that onto the name of the object, hit OK, expand, and I need to give it a good history name. So let's walk through the process of that real quick. I'll expand that in my nav tree just to get my bearings. Here is my history. I'd like to go up to the parent for the name and the folder for the beginning part of the name. So percent parent dot name percent underscore percent parent dot name. I'll go ahead and enable it, and I'm going to set the change tolerance to 5. I'll hit save button, and I'll just view the results down here in the history space. And there it is right there. I'll add an alarm to the hot water temp while I'm in here. So I'll open up my alarm palette and select an out of range alarm from my extensions folder. Drag that to the name of the point, hit OK. expand my out of range alarm extension. And in the off normal text, I'll enter this point has a problem to normal when this alarm goes out of alarm. And then I need to tell it what to do. I'll come down to the off normal algorithm and expand that. I'll put a high limit of 190 and a low limit of 100. Then I need to give it some meaningful text. So, boilers are you can get creative. These are your labs. Be funny if you want. Just make sure that you get something in here so we know what's going on when this hot water temp goes into alarm, and make sure that you enable the high and low limit part of the off normal algorithm. Then I'll go ahead and assign this to my alarm class, and I'll hit save. One of the properties that I didn't talk about in the alarm section of our labs was the alarm instructions. If I hit the double chevron next to the alarm instructions, I can add a instruction set so that when this alarm happens, the person responsible, say it's an apprentice and it's the weekend and you don't want to be the first call, when he gets the alarm, you can come up with a list of things that you want him to do before he calls you. So maybe we have him check power, and then step 2, check the limits, something like that, a list of things to check before they call. We'll hit OK and save that. The alarm instructions will be part of the alarm message that gets sent. If you set the alarm instructions up in your lab, you can go into the console recipient in your alarm service and view the results. So I'll go back to my wire sheet and I'll add those other extensions to the other points off screen.